Stuck solving for x and you don't know why? You've come to the right place for the answers. This is Miss Miller's Math Show.
Woo! Math Show! Oops. Okay, there we are. Most of you are over on this side. All right. Oh my! Thane is doing the Macarena. Okay. They like that part the best. It's a pain in the butt. Right? So what? Okay. All right, you guys. Today we are doing Systems of Inequalities. This is the last textbook section before your group test. No, you guys have a group test tomorrow. Okay, so here we go. In this lesson, we are combining two concepts that we have already done before. We are combining shading and inequalities on number lines and graphing lines, all in one giant concept, okay? So here, we're going to kind of go through this piece by piece. And I have this written really big for a reason. So, oh, there was a request for, yes, come on over. Would you like to be on camera? Miss Jones. Miss Jones just walked in. Would you like to be on camera?
No.
No? Okay. Everybody give Miss Jones a round of applause. Okay. All right. So, everybody draw a graph. Everybody draw a graph on your paper. So we just had a delivery from Miss Jones, our wonderful, wonderful yard duty. Okay, here we go. Somebody refresh my memory. If this was just y equals x minus 4, how would we graph y equals x minus 4? Crawford. Perfect. Okay, so give it up for Crawford. She said -4 and 1 over 1. So what do those numbers mean?
-4 is on the y-axis.
Good.
1 over 1 is go up 1 and you go over 1.
Perfect. All right, give it up for Crawford again.
Crawford!
Okay, up 1 over 1. Okay, so that's how we graph a line. Okay, we need 2 points to make a line, and you start with the y-intercept, and then once you have the y-intercept graph, you use the slope to get the next point. Okay, I'm going over that as if you all have never seen it before, because that is what a lot of people missed on the last test. Okay, now, yes, true. Okay, so, next thing. We have so how many people, clap if you remember when we were shading and inequalities, and if you had less than or equal to, we had a choice between a closed circle and an open circle. Circle. Clap if you remember that. Okay, so now our choice is not open circle or closed circle. Our choice is solid line or a dashed line. Solid or dashed. Okay, so let's think back to shading and inequalities on number lines. If it was less than or equal to, or greater than or equal to, meaning it had the line underneath, was that an open circle or closed? Shout it out. Closed. Okay, so if now the choice is solid or dashed, what do you guys think? Solid. Good. Can somebody explain why that might be? McDonald?
Because when it's a closed circle, then it's just a solid dot, basically, and the lines in the open circle would just, okay, never mind, I don't know if they really
Okay, everybody give it up for McDonald! Okay, so less than or equal to, greater than or equal to, what that means is it includes all the points on the line. Just like with a closed circle, it included that specific point. This means it includes all the points on the line. Whereas if it was just less than or just greater than, that means it doesn't include all these points. So it's a dashed line. Okay, the next choice that we have, lots of choices in these problems. We're looking at this symbol again. Now, how many people can tell me, is this a less than symbol or a greater than symbol?
Greater than.
Less than.
Less than. Y is less
We
than
have a
or
disagreement.
equal to.
So, let's settle the disagreement once and for all. So, everybody agree that it's pointing that way? Did I draw that the same direction?
Yeah.
Okay. If I put a little thing in here, which way is that pointing?
It's totally less than.
It's left,
Everything
which
else is
means less than. Just like if it's going this way, and I put a little line in there, which way is that pointing? Right or greater than. Okay. So that is always assuming that the variable is on the left-hand side, okay? Right or greater than. Okay, so keep that in mind. So you guys tell me, again, is this one less than or greater than? Less. Okay, so let's use some logic here, okay? If it is less than, we have two choices. If it's less than, logically, do you think that means we're shading above this line or below it? If it's less. Less, is that up or down? Down. Below. Cool. I agree with all of you. So that means we're shading all of this down here, below this line. Okay. Whoops. Questions on this? Okay. What do we think? Let's do thumbs up, easy, halfway is medium, and then hard is down. Okay, so I'm seeing lots of this and some of this. Not too many of these. That's okay. All right. Are we good? Can I move it? Oh, and we've got a hang loose sign too. Okay. So next one. 2x plus 3y is less than 6. 2x plus 3y less than 6. All right, so same set of steps that we were doing on the last one. Whoops. Sorry, you guys. Let me do that a little bit bigger. 2x plus 3y is less than 6. Okay. So if I want to graph this line, what would be the first step to graphing it? Casho.
Subtract 2 from both sides.
Good. Give it up for Casho. Subtract 2x from both sides. Okay? So now we have 3y is less than negative 2x plus 6, and then what? All right, give it up for Solorio. Divide by 3. So y is less than negative 2/3 x. Everybody shout out. What is 6 divided by 3? 2. How about everybody shout out? What is 6 divided by 3? That's a little better. Okay. Now, is this one, remember, so sometimes we've had to flip the direction of the inequality. Is this one where we have to do that? Think back.
Well, no, if you divide by a negative, then that means you have to.
Give it up for Casho. Let me repeat what he just said. So, we're not multiplying or dividing by a negative number here. So then we don't have to flip this around. Perfect. Okay. So that's what we're graphing. So let's go ahead and draw a graph down here. So, can somebody start me out? Graphing this line. Y is less than, or you can think of y equals negative 2/3 x plus 2. What is the first point that I want to put on this graph? McDonald? Not quite. Higginson? Positive 2. Good. Where'd you get that? Good. Y-intercept. Give it up for Higginson. Martinez, I saw your hand too late, but would you like to tell me how to get to the next point? Cool. Go ahead.
You follow the slope by starting from the point of the y-intercept and going down 2 and right 3.
Everybody give it up for Martinez. Yay. So what she said is we start from the y-intercept that we just graphed, and our slope is negative 2/3, which means we're going down to right 3. Down to right 3. Okay, now, remember our next choice. We have got a choice of solid or dashed. So, solid or dashed. So everybody, let's do it this way. We're going to take a vote. Clap if you believe that this line is solid. Not a peep in the house. Okay. Clap if you think it's dashed. Yay. Now, somebody convince me that it's dashed. Why is this one dashed as opposed to solid? De Guzman?
It's not like less than or
All right, everybody give it up for De Guzman. It's not less than or equal to. Cool. So draw the best dashed line you can through those 2 points. Dash, 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 dash. Okay, good. So now, last choice. You guys tell me, is this a less than symbol or a greater than? Less than. Somebody convince me that it's less than. Why is it less than as opposed to greater than? Martinez?
because we're doing it according to the y, not the equation.
Okay, good. So I like that explanation. You're doing it according to the y, and it's pointing to the left. Excellent. Give it up for Martinez. All right. So let's get some kinesthetics involved. I want you guys to point up or down. If it's less than, I'm going to turn the camera around in just a second. So if it's less than, are we shading above the line or are we shading below the line? Everybody move yourself in a way. Okay, I think most of us are saying below. That's what it looks like. Okay, excellent. Below is down here. All right, questions? That is the end. Don't overcomplicate. Questions? That's it. We have one more example.
Woo!
Don't you like how I tricked you all?
Yeah.
Okay. All right, last one. Now we're combining two of them on one graph. What do y'all think about that?
Yeah!
We're stepping it up a bit. Okay, here we go. Let's do some color coding here. Let's do y is less than x, we'll do in blue. Then we will do y is greater than negative x plus 3 in red. All right, so let's draw a graph. We already have them in the right format. So, okay, x, y, somebody, all right, how many people agree that y is less than x is the same thing as 1 over 1x plus 0? Is that true? Yes. Okay, can someone tell me how to graph that line? Y is less than x is the same thing as y is less than 1 over 1x plus 0. McDonald?
1 point over on the x-axis.
Not quite. What is the y-intercept here?
The vertical.
True. And how many places do we go in the vertical?
0.
That's good. So that's our first point. And then, McDonald, the slope is 1 over 1. So from that point, we go where?
1 over on the right.
So if it's rise over 1, we rise 1, run 1. That's really hard to say. You guys should try and say that. Rise 1, run 1. Over and over again. Rise 1, run 1. That's really hard. Okay, now, everybody give it up for McDonald. Yay! Oh, we are dimming. Okay, now, in this line, do we have a solid line or dashed? Wait, everybody stop. Stop. Do not go ahead on this. If people are going ahead, stop what you're doing, okay? Oh. You'll see why. I don't want you to, it gets really, really messy if you don't do it this way. You can do it whatever way you like, but it gets messy otherwise. Okay, so solid or dashed? Dashed. Somebody convince me that it's dashed. Why is it dashed as opposed to solid? If I'm looking at that. Barry.
Less than, it's not less than or equal to.
Good. It's just less than, not less than or equal to. Give it up for Barry. You are all very unenthusiastic today, with the exception of a couple of
Yeah.
It's Thursday. Is that the excuse?
Thursdays are not as bad as Mondays.
Thursdays are whack, apparently. Okay. You guys are funny. Okay, now, less than, above or below? Yell it out. Less than is above or below? Below. This is where I want you to do it a little bit differently. Anytime you're putting two on the same graph, from here, I want you all to just draw little arrows from each line in the direction that you're supposed to shade. Again, the reason for that is that otherwise it gets ridiculously messy and hard to follow. Okay, put little arrows downward from that line. Yes.
It's so cute.
Adorable. Okay, next. Y is greater than negative x plus 3. Somebody help me graph this one. Mendez.
You go up 3.
Good, up 3. Excellent. And then from there, negative 1 over 1.
You go up, no, is it down 1?
Good.
And then 1 on the...
Right that way. Good. Okay, everybody give it up for Mendez. That brings up a really good point. That's something that a lot of people get confused on. So if you have a slope of negative 2/3, something like that, the question it often comes up, do we always go left, or do we go left, right, up, down, what do we do? Okay, there are many ways of teaching this. This is the way that I teach it just because it keeps it straight all the time. You always go right, no matter what, always go right. If you have a negative number, you're going down and right. If you have a positive number, you're going up and right. If you introduce left into the mix, it's like a whole big mess, okay? So, you're always going right. If you have a negative somewhere in there, you're going down and right. If it's a positive, you're going up and right, okay? Think of it that way. All right, so can somebody tell me whether this is solid or dashed? Dashed. Somebody tell me why it's dashed as opposed to solid. Because it's good. Casho says it's not greater than or equal to. Give it up for Casho. Go Casho. Go Casho. Okay. Next. Y is greater than. Is that above or below?
Above.
Up. Okay. Now, once you all put your little arrows here, put your pencils down and look at the board. Because you all, I want you to see this. Okay. Clap if you see that these two lines divide the graph into 4 sections. The 4 sections being up here, right here, right here, and right here. Clap if you see that. Cool. Okay. We are looking for a section where the arrows point towards each other. Clap if you see any section, whether it's this section, or this, or this, or this. Clap if you see a section where the arrows point to each other. Okay, here's what I want you guys to do. I want you to make, I'm going to point to different places on the graph. When I get to the place where the arrows are pointing to each other, make the most loud, obnoxious noise you can. All right? You ready? Okay, we'll start here. Good. All right. Can someone tell me why you all chose this place? Barry.
Because that one is shading up and that one is shading down, so they're going to mesh.
Exactly. She said this one is shading up and this one is shading down, so they mesh. All right. Give it up for Barry and everybody else who helped on that problem. All right. Do we have any questions? That's all you guys are doing on homework tonight. So the homework is listed right here. And we are doing extra credit today. Everybody give yourselves a round of applause. Yay.